Hi there. So we're speaking a little bit about a somewhat new to me, at least, dimension in dwarf size concerns, specifically around strings and overflows with strings. This initially presented as corrupted names in backtraces using dwarf's parsing and LLVM's dwarf parsing and generation. And eventually I noticed that the debug string.dwo section in a DWP was larger than 32-bit int max, and it really stands out there in the dump. And that told me that the string offsets in dwarf would be overflowing or otherwise unable to represent all of the strings that are in that string section. This happened especially because of large expression templates, deduced template parameter lists that are very, very significant in a couple of linear algebra libraries and things such as Eigen and TensorFlow. Some of the largest names are over 50,000 characters. So that adds up. There are some source-based solutions we could approach this with, including like renaming long common identifiers, like literally the name Eigen, to be shorter. We could save several hundred megabytes. It would get us below the limit, but is potentially a lot of work to implement. It wouldn't necessarily require users to change their names, but a bunch of finagling in the implementation to add type defs or aliases or things like that. We could remove debug info from some types or variables if they just aren't really relevant to debugging, but hard to judge which ones. It's a bit of a maintenance nightmare to go through and keep doing that. So we're looking at dwarf solutions. Dwarf 64 is the obvious one. Basically, all of the offsets in dwarf become twice as large, and so they don't overflow as easily. But it makes all of the dwarf even larger. And as you can imagine, for these situations, the dwarf is already quite large, and making it larger is not terribly inviting. So one of the options I considered was simplifying template names, specifically the pretty or textual represented names rather than the mangled names. Since they're somewhat redundant in the dwarf, there's a structural representation of the template parameter, float, and a textual representation in the T1 angle float angle. So what if we just didn't include the textual representation and only the structural representation? We wouldn't lose any information. Consumers could still reconstruct the original name, and we could save a bunch of space, a lot of space. In the sort of severe case that is heavily templated, 42% of debug strings, a quarter of the whole DWP file size, and in a more reasonable case, but a large program nonetheless, about half that or a little less than half that. Another thing we could do is we could attack the linkage names, which are also in the dwarf. This is more complicated because they probably need to match the actual names. We could rebuild some of them in the same sort of way that we could rebuild simplified template names. But there's a lot of unknown or correlated issues there, including the linkage names take up a bunch of space in the ELF file itself, in the ELF symbol table. So maybe we could do a combined solution that addresses both of these needs. Maybe it's an ELF solution that dwarf piggybacks on, or a dwarf solution that ELF piggybacks on for error messages. It's not super clear yet, but the benefits could be quite significant. More than the benefits of the simplified template names, in addition to those, like they're completely orthogonal, so these benefits are additive, and more generally applicable. It helps out this other large program we have at Google. Over half of the strings are large linkage names, and a quarter of the overall debug info. This is uncompressed DWP for comparison purposes. So I set out to work on the simplified textual names. I haven't addressed the linkage names at the moment. Most of this is already upstream. I'm just haggling over a few of the finer points and finer details, but the feature is implemented in Clang with 3 modes in the flag. You have to go into Xclang flags to get the special mangled mode, which I've implemented, which includes the original textual name, but breaks it up so that LLVM dwarf dump can pretend that it's not there, rebuild the name, and then verify it against the name that is actually there. This helps validate that the transformation is non-lossy and that all of the information in the dwarf structural representation can be used to reconstruct the textual representation. And I skipped over a few different names that are ambiguous or complicated, or the dwarf just doesn't have enough information, which is interesting in and of itself. But otherwise, this seems to be working quite well. We found a few bugs in the representation and fix a few things along the way, but prototype seems to indicate that this is a viable strategy. I'll hopefully have it wrapped up soon, and the implementation should be all in the open source. And I don't think people will turn it on by default really soon, but it might be a viable change in the way we emit dwarf. Thanks.